Welcome back, boys and girls. So we're just going to continue with the function problems. Remember, in the first segment, we were doing intercepts. We did intercept your x and y intercepts of functions. We gave two examples, which is this example here and this example here. So now we are going to be looking at turning points. We're going to be looking at turning points. Okay, just a quick one. Remember, when we're talking about turning points, we just mean exactly where the graph turns and takes a different direction or the opposite direction. Like, for example, if you have a Cartesian plane with y-axis and x-axis, you can have a quadratic function going something like this, and both on the left and right hand side, it's going to infinity. So let's call this, we can call the graph f of x. So the turning point is more of, see, when the graph goes down like this, at some point it takes a turn. Like somewhere here, it's almost going horizontal or flat, and then from there on it changes direction, it goes up, right? So this here, exactly where it turns and takes the opposite direction, that's our point of interest, and we can call this TP, which is the turning point. Okay, so, and also, I mean, remember, a graph, some graphs have more than just one turning point. Like in trig, you can have a graph that goes like this, where this is a turning point, that's a turning point, that's a turning point, and all of that. But when you talk about quadratic functions, we're only looking at one turning point, which is this right here. Okay, so yeah, with that said, there are many other ways to determine this point here, this turning point. So we're going to be looking at the factorization method, and let me just take all this out, okay, so that we can move on. So I'm going to remove this and show you that what I mean by factorizing. So when you have a quadratic function like this, what you need to do is to put this function or this equation in a form of y equals to a x minus p plus q, right? And if you can put this in this format, therefore your turning point therefore becomes easy, because you can just make it p q. Does that make sense? So that will be your turning point. So every time you get an equation in this format, you just have to change it to that format. So I'm going to show you how to do that, changing from this to that. Okay, so in this example, right? Yeah. Okay. So, looking at this example, what you want to do, okay, you have y equals to x squared minus 6 of x plus 8. So, to change this to that, right? Put x squared as is, right? Minus 6x as is, and then you add, so you add a half of 6, then you square it, and then subtract the half of 6 squared. What I mean by that is, so you'll have a plus half of 6, right, which is 3. You square it, you minus it as well, you square it, and then you continue with the equation, right? Because if you think about it, this here is actually 0, so it doesn't really affect us the foundation or the meaning of this equation, right? So once you're done, you have to actually, from here it's easy because you just need to factorize this right here, and then this you can deal with the calculator. Okay, so moving forward, to factorize, you just have to put x there and square it, and then define what this is. So 6 over 2 is a 3, so you just put that 3 in there, and that's all. Because your 6x is a negative, so when you add 3x and 3x, they should give you negative. So that means they must both be minus 3. And then you put this, in your calculator, minus square root of 6 over 2. 6 over 2 is 3. Squared, it's minus 9, plus 8, that gives you a minus 1. And that's it. So if you look at this is actually in that format. So because if it's in that format, therefore your turning point becomes a 3, right? And a minus 1. Does that make sense? Because the reason why 3 is positive, it's more like you're saying you're taking this that's in the bracket and equate it to 0. Sorry, so you're gonna say x minus 3 equals to 0. Therefore x is positive 3 because 3 goes to the other side. Then it becomes x equals to 3. And that's all. Okay. I know this can be confusing at times, especially what I wrote in blue here. So what I want you to do though, let me give you another example just so you know how to factorize from here to there. Okay. And I'll just make it I'll give you like an easy example. Let's say, okay, just gonna delete this quickly. Okay. And then yeah, so okay, so okay, all right, so I'm just going to give you a quick example. Suppose you have let's say, let me put it in blue. If you have x squared plus a 4 of x plus a 2, again you have to put x squared plus 4x, you add a 4 that you divide by 2 squared, and you minus a 4 that you divide by 2 squared plus 2. Remember, so You understand? So this here, it's that whole zero thing. So if you add and subtract this, it's zero, so it doesn't affect your equation. So moving from here to here, it's quite easy because you just have to put your x there with the square here, and then whatever that's in here, you work it out. Say 4 over 2 is 2, therefore you put 2 there, because this is a positive 4. 2 and 2 must add, therefore you have plus 2. Then you deal with this using a calculator, and then you put it there. That will give you this in this format. Okay, and that's it. So so I hope everybody understands that. Okay, so let me remove this. I'm going to give you one last example of that kind. So when you have, let's say, something that cannot be divided, like x squared plus 3 of x plus 4, right? So again, you follow the same steps. 3x, then you add this 3 here, divided by 2 you squared, that 3 divided by 2 you squared, and then plus 4. Now, to put it in this format, you just have to put your x there. Okay, again, same method, and then you work this out. Obviously 3 divided by 2 is a 1.5, and we're not going to use decimal numbers, so put 3 over 2 as is. 3 over 2, because you have a plus there, then you have a plus sign. 3 over 2 squared, and then you work this out, we work this out with the calculator, and then you put it there, plus or minus, whatever the calculator gives you. All right, does that make sense? So let's move on to the last example. I'm gonna do this example, and then I'll give you one problem for you to work it out yourself. So excuse me. So when you have something like this, you remember, you're trying to follow the same direction or the same methods that we used over here and here as well. So you're trying to put this into that format. Okay, so what you want to do here, you have to be very careful, because you have a minus sign right before the x squared, right? Remember, that equation is something like, I said a x plus, okay, I said minus, okay, so it's x minus p squared plus a q. Okay, so if you have a negative like this, always make sure that your x, you take it out as a factor. You have to be very careful with that, you know. So you have negative out of the bracket, you're left with x squared minus 4 of x plus a 3. Okay, x squared okay, so you have x squared minus 4 of x out. So you have, let me see, so if you're taking the negative out, yes, so you have a minus 4x and a plus 3. So now from here, say you still have that minus, so you're just gonna take it down as is, come down here, put x squared minus 4x, which is the steps that we were following in the previous examples. So you add a 4 over 2 squared, because remember, you're taking this and dividing it. and squaring it, right? Subtract it again, 4 over 2 squared, then you plus 3. Okay? Therefore, you use that quick method. You have to factorize this up to here. And then this you work out with the calculator, right? So to factorize this, you'll have an x. You put your thing here. You square it. We know that a 4 over 2, it's a 2. And because these are negative, therefore both your 2's will be negative, right? If you use a calculator, this is a minus, it's a 4 over 2, is 2 squared. That makes it a 4 minus 4 plus 3. That will be a minus 1. Then you put your bracket, right? So from there, you're not done, because remember, you still have this negative out here as your value of a. So to make it a value of a, you bring it inside by multiplying whatever that's in bracket with the negative. So you'll have a negative x minus 2 squared minus times minus 1, you'll get a plus 1. And therefore, because now we have successfully put this equation in this format, therefore we are able to take out a turning point from there. And therefore your turning point will be a positive 2 and a 1. So it's a 2, 1. Okay. Alright, so that's how you do this, the turning points. Thank you everybody for tuning in. Please go through this example number 3, get the turning points for this, and if you're struggling with it, let me know in the comment sections, or hit me up on WhatsApp, hit me up on Facebook and Twitter if you like, and also on YouTube as well. Thank you for tuning in. Until next time, bye. How long was that? Shit. With it, let me know in the comment sections, or hit me up on WhatsApp, hit me up on Facebook and Twitter if you like. And how long? Why? 28 minutes.
What?
Oh, well, maybe Facebook is recorded up.
Yeah,
so before, because more Facebook is 18, more YouTube.
Hey, YouTube ki bole je sharp. From Korea, more Facebook kama kale ki. Again, किसी problem little level खांसे जो है ऐसा. So एक draw लोड क्या लेवे? पंचा का दी, प्ले लगा दी intersections प्ले लगा सब ले लगा turning point. अरे खांसे लस्ती ले लगा, प्ले लगा turning point.
And because there's 2. Let me tell you there was intercept and load. Welcome back. And then today I'm doing intercepts, turning points.
I was doing the same thing.
Yeah?
I did the same thing. Go YouTube sharp. Go Facebook, I think it's all with the
intercepts, turning points.
I was doing the same thing.
Yeah?
Go YouTube sharp. Go Facebook, I think it's all with the